This is video number 7 in our gram, mole, atom, and now molecule conversion series. This is actually going to be very similar to mole atom problems. As a matter of fact, it's exactly the same except for a word. A lot of people see the word molecule and students freeze up. They say, I don't know how to convert from mole to molecule, when actually they know how. They just don't know they know how to do it yet. So the first thing I want to talk about real quickly is the difference between a molecule and an element. Remember that an element is just one of those single things that you see on the periodic table. Hydrogen, nitrogen, bromine, chlorine, fluorine, the things you can literally look at the periodic table and see. A molecule is what you have when you have a combination of those elements. And sometimes when we're working in chemistry, most of the time actually, we're working with molecules. We very rarely are working with individual elements of any kind. So it's important to be able to understand these questions and do the math in terms of molecules. So this may be a page that you want to maybe freeze these frames and take a few notes. My abbreviation for molecule is going to be MC. A lot of people use that. Some professors don't like it. So if you're in college, just be aware they may prefer you write out the word. You don't want to abbreviate it mole or M-O-L-E, because then it looks like mole and it's very confusing. So MC is a good one. Now, what we already know is that there are 6.02 times 10 to the 23rd atoms in a mole. And we've actually talked about the fact that there are 6.02 times 10 to the 23rd anythings in a mole. So that leads us to understand there are 6.02 times 10 to the 23rd molecules in a mole. You know, we've talked about the fact that that is just an enormous number, and it's really not useful for most things, except for counting very tiny things like atoms and molecules. So because you've really already had this math, I'm going to actually do the mole to molecule and the molecule to mole on the same lesson. And I've already started writing on this because I ran out of storage space recording earlier, and I had to stop and free up some things and delete some videos. So that's why I've already got something written right here. So let's look at number 1. How many molecules are in 0.75 moles of water? So we're going to write down our given, which is 0.75 moles of water, long line, short line. And now we're asking ourselves, do I know how to get from mole to molecule? Well, what you know is that mole is going to have to go on the bottom here because it's on the top here. And yes, we can go from mole to molecule because we know there are 6.02 times 10 to the 23rd molecules of anything, in this case water, per mole. Moles cancel, and we are ready to do our calculation. So all we're going to have to do is multiply that 0.75 times 6.02 times 10 to the 23rd, and the answer is 4.52 times 10 to the 23rd. So I'm just going to squeeze it in here. 4.52 times 10 to the 23rd molecules of water. So essentially, we're doing the same thing we did when we went from mole to atom. We're just multiplying by Avogadro's number. In this case, H2O cannot technically be called an atom because it's a molecule. That is the only difference. It's really just a word. So now you're saying, oh yeah, I already know how to do this. So let's look at number 2. How many molecules are in 1.4 moles of carbon dioxide? So we write down our given, 1.4 moles of CO2. Long line, short line. We know mole's going to be on the bottom. I'm just going to go ahead and write that down. And where am I going? I'm going from mole to molecule. We know there are 6.02 times 10 to the 23rd molecules of CO2 per mole. Moles cancel, and all you have to do now is calculate this. So we're going to punch into our calculator 1.4 times 6.02, exponent button 23, and you should get 8.43 times 10 to the 23rd. So 8.43 times 10 to the 23rd molecules of CO2. Now, I'll stop right here and address a question you may have. A lot of students will say, where's the molar mass? Why aren't you using that? Because you've gotten used to, when you see a molecule, finding the molar mass. You just simply don't need it here. They did not give you grams, and they did not ask you for grams. So grams are not any kind of part of this problem. Again, we're just looking at how many. If I said you have 24 people, how many people is that? You would say 24, because again, a dozen is 12. Even though a person is made up of lots of different parts, we're not asking you how many different parts they're made of, just how many people, like the whole thing. A molecule is kind of like a whole person, if you want to look at it that way. So let's look at number 3 now. 5.2 times 10 to the 24th molecules of SO3 equals how many moles? This time we're flipping it around and going the other way, and those of you who've been following me kind of know how I do things now, so you probably already know exactly where this is going. So we're going to write 5.2 times 10 to the 24th molecules of SO3 we are going from molecules to moles this time. Mole's going to be on top because that's where we're going. How many molecules are in a mole? 6.02 times 10 to the 23rd molecules of SO3 per mole. So this time we are dividing. We're going to divide 5.2 times 10 to the 24th. This is such a good time to practice putting those exponents in the calculator. Never assume you can do it until you've actually done it. Divided by 6.02 times 10 to the 23rd, and that gives you 8.63 moles of SO3. Now you might look at that real quick and go, wow, I was working with these, getting these really big answers, and now I'm getting a much smaller answer. Well, that's because in the first two you were solving for how many individual molecules. You know that's going to be a really big number. Here, you're looking at, hey, I have this many molecules, how many moles is that? Again, that's like me saying, you've got 36 cookies. How many dozen is that? It's going to be 3 dozen because there's 12 per dozen, and we would divide. So again, you can compare just about anything in chemistry to a recipe. Makes things a lot easier. Now, we're going to do one more problem like this, just to make sure everybody's got it. So one more going from molecules to mole. So this time we have 8.0 times 10 to the 22 molecules of PCl3. You don't even really have to, you don't have to know what that is. You're just looking at how many. You'll learn what it is later. I'm going from molecule to mole, so mole is going to go on top. I know molecules goes on the bottom because I'm looking for it to cancel. How many anythings are in a mole? 6.02 times 10 to the 23rd molecules of PCl3 per mole. We're going to divide. Remember, what we're really doing is you're multiplying everything on the top together, write it down. Multiply everything on the bottom together, write it down. Do you really need to write it down? No, because you've only got one thing on the top and one thing on the bottom. So 8.0 times 10 to the 22nd divided by 6.02 times 10 to the 23rd equals 0.13 moles of PCl3. And that's it. I think I'm probably going to have one more video in this series. I will probably do a gram to molecule, and in the same one probably do molecule to gram, because again it's the same math you've seen. We just use atoms to start with. If you're watching these videos, so what you're seeing is not fancy. These videos are intended to be just like someone sitting down beside of you and saying, hey, here's how you do this problem. Let's write it down. There are a lot of fancy ways to do these, and there's some wonderful videos out there with all kinds of animation. I enjoy watching those. I encourage you to. But sometimes it's just really important to put that pencil to paper, write it out, talk it out, put it in the calculator to build up that confidence in chemistry. So look for one more video in this series, and then we're probably going to move on to another topic.